Okay, good afternoon. Welcome all to this third talk of the webinar series Data Dialogues. This webinar series is co-hosted by IUTX and CSP, IISc. And I'm very pleased to welcome our speaker today, Dr. Yogalakshmi Jayabal. And the title of today's talk is Public Transit Data Analysis. And I think this analysis will be presented in the context of BMTC data. Yogalakshmi is currently a postdoctoral research associate with SISTA, which is a interdisciplinary center for infrastructure, sustainable transportation, and urban planning in IISc. And in SISTA, she's leading the design and development of computational framework for evaluating operational headway management strategies for increased reliability in public transit. She did her doctoral studies from IIIT Bangalore, and she has 7 years of experience in software industry and has been in IT research for 4 years. And her general interests span algorithms for data analysis, heterogeneous data analytics, and public transit demand modeling. We are very excited to see the topic today because I'm assuming many of us have been at the receiving end of the transport issues in Bangalore. So really looking forward to the talk, which hopefully some solutions are emerging. So once again, I extend a warm welcome to Dr. Yogalakshmi, and without further delay, I would request her to begin her presentation. Just a couple of comments. As you all know, this talk is recorded. I think recording would have already started. And for any urgent queries, please feel free to interrupt. However, towards the end, we'll have a Q&A session. And please, you can type your questions in the chat window or raise hand towards the end for any questions. I think my colleague Jyotirmay Datta is moderating, so he will make sure we accommodate as many questions after the presentation. So once again, welcome Dr. Yogalakshmi. I think over to you now.
Thanks, Mr. Abhay, for the kind introduction, and thanks for giving an opportunity to share my work. Let me get started. Let me share my screen. Hope the screen is visible.
Yes, it is. Maybe you can do the full presentation.
Yeah.
Perfect.
Good afternoon, one and all. I'm Yogalakshmi from SISTUP. Today, I'll be sharing our analysis work that we carried out using BMTC data. Today's agenda for the presentation will be, I'll be presenting a brief introduction to the BMTC transit data, followed by the methods and tools that we use to understand the data in little more detail, and the preliminary results that we obtained upon analysis. I'll delve little more detail into what is called as platooning of buses, why it is important, and the solutions that we have proposed towards reducing the same, and some of the applications and the field pilots that we have planned to carry out, and the challenges that we have faced so far and the opportunities that lie ahead. Just to start with, we all know that Bangalore is the 5th largest city in India with a growing population of 12.3 million people as of 2011, and it will grow. As we know, it is expanding. And BMTC is the public transit agency that helps people move across in the city. And as of 31st January 2021, BMTC operates out of 45 depots in the city, and as many as 47,000 trips are made every day, with a fleet size of 6,565 roughly. And this stats in my view has reduced when compared to pre-pandemic 2 years before. It was roughly around 79 to 80,000 trips. It was making 79 to 80,000 trips every day, which has come down to 47,000. So it's definitely a reduction in the number of trips and the effect of pandemic that has created upon the transit. So given that picture, BMTC was kind enough to share their data with us for the purpose of analysis. Some of the data that they have shared with us were the basic information on the routes that are operated in the city, the different bus stops that are visited by different routes, their schedules, and the ticket sales data from their electronic ticketing machines. So some of the buses are provided with electronic ticketing machines, which are GPRS enabled. And apart from these, last but not the least, the GPS lat long data from the automatic vehicle units that are fitted to their buses. So these are three different types of data that are provided by BMTC to us.
So,
So
Yoga, just one quick question, just about this data. Is the ABL units present on all these 6,000 buses, or is it from a subsample?
it is present in all the buses. Right, with the previous vendor. Right now there is a vendor change with BMTC. So all the analysis that I would be presenting is from the historical data. So I believe there is a vendor change, and all the data that were provided to us by BMTC, which were captured by the previous vendor. So back then it was fitted to all the vehicles.
Okay, great, thanks.
Um, so some of the preliminary analysis that we wanted to carry out to understand data in little more deeper is what are the distribution of routes, because we have straightforward information on what are the routes and what are the stops those routes will be visiting. This distribution of routes based on the number of stops that would be visited. And based on the ticket sales data, we wanted to look at hourly occupancy in different routes and the load profiles of various trips in each of these routes. And also the occupancy between different origin destination pairs at different times of the day. So these are primarily looked at from the ticket sales data, which are coming from electronic ticketing machines. There are also manual tickets and pass tickets. Our analysis could not get our hands to those data because they are not either they were not digitized, or it was not available back then. The pass data, it is only available at aggregate level of number of passes sold per month, and not any more detail on the passes are available to us. And also from the GPS data, we try to identify spatially and temporally where the buses are bunching together. So I'll delve more detail when in a short while. The major tools that we use to perform these analysis were Python, R, and some of the visualization libraries that were supported by them. And in addition, we also use Tableau and other standard visualization tools for visualizing the analysis. To start with, let me just give you the distribution of routes based on their number of stops that are visited. The number of stops are given and at outer of the pie chart. Um, so the numbers that are present on the pie are the percentage of the routes. So we can see that 35.7 percentage of the routes cover up to 20 to 40 stops, whereas 17 percentage roughly cover 40 to 60 stops. So if we take these two together, at least 50% of the routes cater to long distances in our network. So that's a that's a big reveal. So if 50 percentage of the routes are covering long distances, that means there could be overlaps, there could be more number of buses uh, meeting each other. There could be a lot of other questions that we can raised that can be raised based on this information. So going to ticket sales data, a snapshot of ticket sales is presented in the screen. As many as 50 to 60 parameters are captured for every ticket by the BMTC. every single row. Yeah. Hello. Um,
I think
any
the mic
question?
was on. The mic was on, and I muted them. Sorry for
Oh,
that.
okay. Yeah, no issues. So I just thought it was a question for me. Every single ticket has a row in the database, and it can be for a single ticket or a group ticket. When I say group ticket, that means it can represent a ticket being purchased for more than one person. So out of the 50 parameters, the parameters that were interest to us were only around 10 to 14. So some things like number of tickets sold, ticket date and timestamp, where the person boarded, where he alighted, which vehicle number in the ticket was punched, the route number, the schedule number, etc. So these are the basic details that we took out from the ticket sales to further analyze the hourly occupancy and other things. This is one of the sample analysis from V500D. V stands for Volvo, and V500D is a route that is operated from Central Silk Board to Hebala on Outer Ring Road in Bangalore, covering about 30 kilometers roughly, and it visits almost 43 stops in one direction and 39 stops in other direction. And despite being a Volvo bus, we can clearly see there is more demand for this bus. All the four figures here represent four different weeks in December 2018, um, first week to fourth week, and the x-axis gives every hour of the day in that particular week, and y-axis is the number of tickets sold in that particular hour. So we can clearly see repetitive patterns across days and then across weeks, and always the peak demand seems to be between 8:30 to 10:30 in the morning, and evening 5:30 to 8:30 in the evening. So probably there was slightly less demand in the fourth week of December due to some holidays, but otherwise we can see that this corridor that is being served as 500D has higher demand for across all the stops that are being visited by the route. So these sorts of analysis will tell exactly what are the peak periods and off-peak periods on different routes, and uh, how to go about the fleet sizes and the frequency of the buses. Um, so
I mean, just a
any
curious question. What is the peak? I mean, we're not able to see on the graph, like what is the number of, what is the
um,
peak occupancy during, say, 8:30?
it is as high as 800.
Oh, this is for one bus? No,
Uh,
this is
uh,
all the buses.
yeah, all the buses on that route at that point of time.
Okay, good. Okay,
Yeah,
thank you.
that's why there are, as despite being a Volvo, there are many buses, and it also makes up as one of the frequency routes being served in Bangalore. So probably there are other 20 high frequency routes that we have identified. Some of them I can mention are um, um, 600F, which serves from Banshankri all the way till Atibele or till Electronic City for sure. KIA 9, which is a service running till airport. I'm not exactly sure from which area it serves. 335C from KR Market to Lal Bahadur Shastri Nagar. Um, there are other buses 402, 401K. So there are 20 high frequency routes that we have identified, and most of them display this behavior.
Okay, great.
Yeah, yeah. Moving ahead. Okay, so next we were looking at the load profiles in each of the different trips made by the routes. So this is one snapshot of 335C. This scatters from KR Market all the way till Lal Bahadur Shastri Nagar. So this is for this is in a particular week, which is between 2nd and 7th of December 2018. So this analysis will give a quick snapshot of different uh, journey times of different trips. Whether in the morning, what were the journey times like, and in the mid afternoon, is it increasing or decreasing, or towards the evening, is it increasing or decreasing? So the comparative journey times can give a quick glimpse of the traffic that are usually there in weeks, and can be used to plan the trip times. When the schedules are being planned, the journey times can be accordingly adjusted, and the circles that are displayed at each of the intersection points in the grid are proportional to the demand that was seen in the ticket sales data at each of those stops. It will also tell us whether roughly the route is completely occupied throughout, or the bus is completely occupied throughout the stops, the crowding information. Um, since it is not available to us in real time, it may be difficult to get these sorts of analysis in real time, but for the historical data, this is definitely possible, and this will give a quick picture of the sorts of demand and the revenue that can be estimated, or uh, uh, the uh, number of people that are boarding the buses, are alighting at different stops, can be uh, we can get those numbers quickly. Um, okay.
Yogalakshmi. Oh, okay.
Yes.
Yeah, well, go ahead.
Yeah,
Sorry,
yeah.
just
Tell me.
I wanted to know that load profile. Can you just explain a little bit what is on the y-axis?
The y-axis are the different stops in visited by the buses. So for the x-axis is the timestamp. Say for every hour there is a grid line passing through, and
Yeah.
y-axis is two different directions, the circular trip. So from Lal Bahadur Shastri to KR Market, and then from KR Market to Lal Bahadur Shastri Nagar again. So
Okay.
it's a full
That's
circle.
probably that's where there is a break in between, right?
Yeah, that's the break to
And
differentiate the different directions.
okay, and these different color of the circles, what are they representing?
The every single color represents one bus,
Hmm. Okay, okay.
and the trip that it made from, say for example, here the trip that started at around 8 o'clock with the blue line lasted till
Hmm.
around 8:30, or just before 9 o'clock. It ended the trip at KR Market, while the trip that started after 8:30 with the red bus, probably there could be loss of data, or mispunched data, due to which it is showing that it ended the trip only at way past 10.
And the
Uh,
size of the circles are representing the
the
occupancy. Am I right?
Yes, occupancy at that
No.
particular bus station when it
Right, right.
reached the
Hmm.
time and the station. Based on the time and station,
Hmm.
so the occupancy is computed based on the number of tickets
Hmm.
boarded and alighted at that stop. So who are currently still seated inside the bus. So occupancy is directly equal to who are currently still
So
seated in the
basically,
bus.
it is computed based on the number of tickets the conductor is issuing, right?
Yes, yeah. So from the ticket sales data, we will be able to know where when a ticket is punched, whether the boarding point of the ticket and alighting point of the ticket. So we will know at each station how many are still remaining in the bus after people have alighted. So it's based on that.
Okay, thank you.
Okay, just at that point, I just want one minor point I wanted to clarify. These are tickets which are coming from the point of sale equipment. Are there like how do you account, or do you account for the passes that are given?
No, the passes. So, like I said before, we don't have any information on the passes. We only know that there was, say, 40 percentage of passes were sold this month. 20% out of the revenue, the information that we get from BMTC is 20% is of the revenue is from passes, or 30% as an aggregate number, and we don't know the exact numbers as well. So this only accounts for the ticket sales from the electronic ticketing machines that were in the buses. So that's also another drawback, why it can't reflect the real situation. So
Correct. That maybe the passes can have QR codes which need to be still scanned,
still,
and then maybe that may help. I mean, but
yeah,
that's not.
there is actually provision available. One of the parameter that could be captured by the conductor is whether the person who is getting in has a pass or not, whether it is a student pass or a daily pass or a monthly pass. So he
Yeah.
can just make an entry, so that is still available in that device, but that is not being made use by many of the conductors. So we see a lot of discrepancy. Some of the crew members who have made an effort to enter these information, we see as ticket as punched with price 0 and the pass information, but otherwise we don't see for many of the routes these information. So
Okay.
it also gets difficult to include them in the analysis.
Cool.
Next is analysis of different origin destination pairs throughout the time of the day. So the top left figure shows a particular origin destination pair. Sorry for the size of the figure. So this, we can see that throughout different hours of the day, there is a demand still existing between those two points, origin and destination. Whereas on the top right and the bottom right, we can clearly see two peaks, morning peak and evening peak, where there is demand. Rest of the day, the demand is very low compared to the peaks. And on the contrary, the bottom left also shows a demand only in the morning peak, and it dies down towards the evening. So, uh, for example, the behavior exhibited by the origin pair, which is on the bottom left, one such example that I can say is pre-pandemic, the buses operated between Central Silk Board and ITPL. There would be a morning peak, and it dies down towards the evening, because the direction of the trip is towards the work. And in the evening, there is a shift change, that is the peak is in the on the evening in the direction ITPL towards Central Silk Board, the Maratalli and the Kundanahalli gate, though towards that direction. So in the evening, there is a peak, that is people movement is seen from ITPL or Maratalli or Kundanalli gates towards Central Silk Board. Whereas in the morning, there is demand or people movement seen from Silk Board towards those places. So these kind of give us, suggest us the frequency that and the frequency at which the buses or can be operated at between different OD pairs at different points of the day, which can cater to the demand appropriately. So these are some analysis that we performed using the ticket sales data. Coming to
So just a minute, Lakshmi,
yeah.
if you could. So here the vertical axis is showing the sale of the tickets, right?
Yeah, sale of the tickets. Y-axis is different hours in the day again. So
Y
sorry,
axis is different.
Y-axis is the sales and X-axis is the hours. Sorry.
Okay. And from the graph, how do we figure out the direction of the bus, whether
Uh,
from origin to destination or otherwise?
so this is between a particular origin and destination. We choose on the um, text boxes or the drop downs that are available. On the left here, it says which OD pair that we want to examine.
Mm-hmm. So
So
this is
for that,
for a one bus, right? Or is it for a route?
this is for a single OD pair. So OD
Okay,
pair
okay.
can
Can
be
have multiple buses, right?
yeah, multiple
Mm-hmm.
buses, and
Mm-hmm.
within a route or across routes also possible, but here mostly within a route.
Mm-hmm. So basically these four graphs are showing four different OD
Different
pairs.
types. Yeah, for different OD pairs and different types of demand. So for the top left, this figure has demand throughout the day. This
Mm-hmm.
OD pair has demand throughout the day. So it is not it is not decaying towards the mid day or towards lunchtime and then increasing. But on the top right, we can see there is a morning peak, clear morning peak, and a clear evening peak, whereas towards other time of the day it's comparatively low with respect to the peaks. um, this is a complete contrary, that there is only morning peak and towards the evening it's dying down. So it clearly suggests that this OD pair will have demand only in the morning. So the directionality, the origin and the destination plays a critical so that whether the buses are moving towards work place kind of whether the land use is of entertainment or work or how school etc determines the demand that is placed. So clearly we can see from the land use type, we can associate why there is huge movement only in the morning and there is really very less demand, almost as zero towards the end of the day. So that gives a picture of um, no suppose I want to increase the frequency of buses in this between this particular OD pair. When do I do so? Only in the morning session, because morning is when there is lot of demand. Evening there is no need for that many buses. So the frequency can be as low as possible, just to cater to the lower demand here.
Right.
So yeah, so the going forward, next data that we looked at is the GPS data from the AVL devices that are fitted within the buses. This is a snapshot of trips directly obtained from GPS for October 1 to October 4th, 2019, 500D. This is not Volvo, because that time we did not, probably we did not want to look at Volvo at this point of time. We wanted to look at ordinary services as well. The here we can clearly see there are some breaks, white patches. So some of these places, when deeply examined, sorry, again here x-axis represents different times of the day. The y-axis represents different stops, like in previous figures. Central Silk Board to Hebala, and then there is a small patch break available, and then from Hebala back to Central Silk Board. So right now I have, instead of names, I have just given the cumulative distance that is covered by the bus stop. Uh, so the white patches that we see here, when deeply examined, tells us that there was no data available during that period. Probably could be because of communication failure or missing data packets, or any other reason, because the data is not available in the server itself. And there are some partial lines also that can be seen. They are basically because some of the trips are partial trips. For example, the buses that start from Hebala come all the way till either KR Puram railway station or till Marathalli. Instead of coming to Central Silk Board, they take a U-turn at Marathalli and then go back to Hebala. Uh, so these are partial trips or cut trips, can be called either way. The some of these partial or cut trips are scheduled once, but many of them that we see here are not scheduled. So the other exercise that we also carried out is uh, trying to match the trips that are available from the GPS data against the trips that are scheduled for the corresponding day. So the schedules are pre-planned ones, which are available in a different table in BMTC. So when we try to match whether the same trip that we see in GPS data is available, is being scheduled, or vice versa, whether the scheduled trip is being available in GPS, um, we only see about 40% match. Other trips we are not able to match, probably because the trips got cancelled, and there is no exact time match also being captured. When trip starts, it is not directly sending any indication to the server that a particular trip that was planned as per the schedule is starting now. So the dynamic capture is not available. So we don't know for sure which trips are cancelled, or which of these trips have been, which of these full trips have been made to become partial trips, and so on. Uh, so so these sorts of information will help us know, capture the exact reasons in more detail. So why do we see the patches apart from say communication failure, or say the missing data packets which are from the network's perspective. Other things can be examined and figured out a way to analyze, but only the network, whatever data packets we are missing from the network side, there is no way to get it back at that at with the given infrastructure right now. Though the BMTC claims that these packets are saved in the backup server, but since we didn't have access to all of that, we don't know whether how they are being captured exactly. Um, so given this scenario, and we also see that there are some
Quick
lines which,
question, Yogalakshmi, the trip ID does not come in the packets given by this thing, right? See, basically in the static schedule, they must have given some kind of a trip ID, and is that trip
yes,
ID okay? But that trip
yeah,
ID is not included in the dynamic packets.
yeah, that is not
You
included in
have to
the dynamic
basically make
packets.
the decision based on, I mean, closeness of that, right? To figure out whether this must be this particular trip or something else, right?
Yes. Yeah, so we try to match the 40% match that we obtained also is based on different factors. One of them is its proximity to origin and destination, and the timestamp at which it started. So if the schedule says it should start around say 6:15, and if we see a trip that has actually started between a time gap of half an hour, 15 minutes plus or minus, say 6 to 6:30, we try to say, okay, probably this is the trip. So that's how at least we are able to get 40 percentage match. Otherwise we don't see any exact match, because like you pointed out, there is no trip number being captured. Though the trip numbers are generated in the schedule, they are not uh, when in dynamic nature they are not captured. So
But I mean, that's just like we get one data from one city where actually trip ID is included, but that doesn't mean it matches the static schedule. So we still have to do that matching, what you are saying. It's not
okay.
always, even though the trip ID is there in the static schedule, the route which a bus is taking sometimes does not match. Like it either stops before or something like that, and it anyway doesn't match the exact time start or things like that.
Yeah, exact time start, yeah, we have never seen exact time match,
Right.
like you pointed out. So like I said, the closeness or the proximity to origins, and whether it is starting from that place, and based on the order of the stops covered. So where are the various factors that we have considered to categorize a particular trip being no matching with the schedule. So first is the route number, and apart from that, within the route number there are different directions. So given a direction, and the ID of the AVL unit that is fitted in the bus, um, that is matched against the route number, right? So whether as per the plan, that whether we are getting GPS data from that device ID, and those pings are in the path of the route that was designated. So the geofencing within that route path. So whether these are available at the preliminary stage. After that, we say probably it's a valid, these sets of pings are valid pings for this particular route on that day, and then we go ahead and match whether it falls in any of the trips that are scheduled. So there are lots of pre-processing steps that has to be done to even capture the trip in dynamic nature.
Correct. Yeah. Thanks.
So given these preliminary analysis, we wanted to delve little more in detail regarding the platooning of buses, and what are the approaches that we can take to reduce it to some extent, though not eliminate it. It's very difficult. So what exactly is platooning of buses or bus bunching? The picture on the right bottom shows two buses arriving one after the other uh, with the same route number, say 273, which means a person standing at a bus stop, if he sees more than one bus that is belonging to a route arriving one after the another, then we say the buses are getting bunched. So what are the side effects of these? The subsequent bus on that route will be delayed, will be arriving little late at that stop. So delayed arrival of subsequent buses, which means the passengers who are waiting at that stop to board those buses will eventually have longer waiting times. And another side effect is, because there are a lot of passengers to cater to, the bus which has actually arrived delayed at that stop will be overcrowded beyond its capacity, and there will be no passenger or very few passengers left for subsequent buses that may arrive no very quickly. It leads to ridership and revenue loss, and it also affects the reliability of bus arrivals. So the overcrowding is basically because we don't know uh, when the next bus will arrive, because there is no reliability or the guarantee that probably I should leave this bus because it's overcrowded and I will get a bus in another 5 minutes. So that sort of reliability is not present, and hence these are the side effects. So a quick video. Um, sorry. Sorry. So this is a small video capture showing how the buses tend to bunch. The circles that we see here are different buses which started with even gaps between them, and the spokes at some point at intermittent spaces in the circle are the demand at that stop. So we can see different demands or people arriving at different rates at each of the stops, and the distance between the buses getting reduced. Because there are large passengers waiting, this bus has to wait for some time to get no for all the passengers to board in, but eventually the bus which was behind it caught up with this bus and leads to bus bunching. So which leaves with no or less passengers for other buses. It leads to reliability issues basically. So that's the prime reason we have to look at bus bunching and try to take some steps towards reducing the same. Some of the strategies that are proposed in literature to reduce this bus bunching effect is delaying the departure of buses to maintain headway. That is, to maintain the time gap between the previous bus that left and the current bus, probably delay the departure of some specific buses, or skipping the stops. During the journey, probably some bus can be suggested to skip some of the stops and go ahead and overtake other buses that are on the route. And the third measure is reducing the speed during the journey to maintain head time gap within buses. So these are predominant approaches that are available in literature, and some of these are available as systems in some places. One such example pilot solution that is available is in the city of Spain called San Sebastian. D-Bus is the transit operating agency, and Tempo is a system that has been jointly developed with the University of California, Berkeley, and is being deployed by D-Bus for this particular city alone. And it helps high frequency buses to be in sync. So the left three user interfaces that we see here are the in-vehicle alerts that are given by the system or the suggestions that are given for the driving speeds. So whether the driver should maintain the speed or slow down his speed to match up so that he doesn't go and end up right behind the previous vehicle. So these are in-vehicle alerts that are communicated to the different bus drivers. So these user interfaces are kept near the driver's view. So the other sort of alerts, the right two alerts are departure alerts that are provided by the system. For example, if the bus has to get delayed, here it says it has to delay the start of the bus by 7 seconds at that particular station. So it has to, the bus has to wait, which means the driver should wait at that particular station for 7 seconds and then he should depart. So these kinds of signages are communicated from the system to the driver when visiting at different bus stations. So these are some of so similar are also existing at other places as pilots. Based on these, the suggestion that we also propose to BMTC is delaying the departure of buses at control points. The control points are nothing but the bus stations, but with some specific purpose. So the figure on the top, we can see that bus 2 and bus 3 have very less gap between them. So we term them as bunched buses. So the measure that we are taking to curb or separate these two buses to prevent the bus 3 being not following the bus 2 is at some specific station, we want to make the bus 3 wait for some units of time before it can start or before it can depart from that station. So this will try to optimize the gap between different buses that are on the road. So this is the primary strategy that we wanted to propose to BMTC. Um, for this, the architecture that we have proposed is consisting of a user interface. Mainly, the user interface is for the operating transit agencies view and analysis, and the middle layer consists of the compute layer, and the third one is the databases, primarily consisting of schedules, route information, and the GPS data from the AVL units. The compute layer is where the most of the things are getting captured. So we will the assumption here is that the compute layer will have access to the AVL pings, and using the AVL pings, it will process them to generate the trips and the trip direction of that particular route. So, for example, in say in 500D, there might be some 40 buses designated for a particular day, and 20 of them may be starting or departing from Central Silk Boat, and another 20 may be departing from Hebala. So we need to identify uh, pings from each of these 40 different buses and their directions on the fly. So there is it should be handled programmatically at the algorithm level, and once they are detected, like I said, the control points are nothing but specific bus stations with some purpose. So we need to identify bus stations which have enough space where the bus can be stopped for a while. Given our scenario and the corridor that we have selected, the 500D corridor, except for the origin and destination, we are not able to think of other places where we can slightly delay the bus.
But
So
now
we
he's
plan.
not feeling.
Yes. Hello. Yeah. What is the question?
I think it was somebody's mic. Sorry, but go ahead, Yogesh.
Yeah. So um, since the corridor that we have chosen for pilot is 500D, and apart from origin and destination, we are not able to think of other bus stations where we have some space available to delay the bus. So we are now designating. We are probably trying to delay the bus either at origin or at destination. That is either at Silk Board or at Hebala. So as the buses approach Central Silk Board, we would try to see whether there are buses already present or some other buses that are stationed at that stop, and or how many or what was the time the previous bus departed from Central Silk Board, and few other parameters that we consider before computing what is the delay that should be employed to the bus that is approaching the central silk board. So based on these, there is a delay that is computed and communicated to the bus that approaches the central silk board. So apart from this delay, there are other plots and reports that are generated, which can be consumed by the user interface to render them. So as and when the user clicks on different things, for example, the live look, if he wants to look at the live location of buses, we have provided and we have developed an user interface for that. And if he wants to see what are the hold times that have been applied earlier, or how many so since we are only trying to delay at 2 points, and we are not making any assumption that the buses will not overtake each other. So during the journey, the buses may overtake each other. That means at some particular point, it would have just two buses would have just come into contact with each other. That means if they come into contact with each other at a given stop, then we term them as bunching. But during the journey, they can overcome each other's cross each other during the journey. So these sorts of reports are also we are providing to the user interface. So before taking to the field, we wanted to simulate these things and see how and whether we are actually able to separate the trips and not give some gap between different trips and not overlap the trips. So the figure on the left shows the simulation without any holding strategy applied. That is, we have not delayed any of the buses. So this is a simulation. So for example, for this simulation, we took October 3 scheduled trips, and based on the start times that were mentioned in the trip, the trips are just simulated. So the number of buses are taken into consideration. For example, there could be some 20 buses that are plying in up direction, and 30 buses that are 20 more buses in down direction. So for a given bus, there could be, say, 6 trips or 4 trips that are planned as per the schedule, and those 4 trips need not be consecutive trips. There could be 2 trips planned in the morning and 2 trips planned towards the evening. So all these things have to be accommodated in the in the simulation to depict the real-time scenario. So taking all those into consideration, we have tried to simulate, and just without any delay that is applied to the buses. So if we look at the schedule, we'll be able to see that BMTC explicitly plans um, uh, for departure. So for example, 6 in the morning, there are 3 buses planned to depart from Central Silk Board. Similarly, at 8:30 in the morning, there are 2 buses planned. Likewise, there are some explicit bunching being planned. Probably I don't have the right word other than bunching. So explicitly, there are 2 or more trips that were planned at the same time based on the experiences that they had. Probably due to the demand, they just since it was just a schedule that was entered, it said 3 buses are to be departing at 6 o'clock from Central Airport. So if those 3 buses are completely occupied, probably they would depart at the same time, and a next bus could have been delayed. So the system should, instead of departing all of them at the same point of time, probably what we are looking at, system should slightly include some delay, a minute or 2 to 3 minutes delay between these trips, so that they get spanned and don't end up leaving long gaps between buses. So that's the simulation purpose. So we were able to see that trips. So we can see there is a there is a white patch available, which is reduced to some extent in this simulation. Similarly, in the evening, there is a big gap that is available, which has been reduced. So we were sure that it will curb bus bunching to some extent. So we wanted to take it to field. Um, to take it to field, there are additional requirements that are to be met. Some of them from the algorithm or the software hardware side, and others are from the BMTC's support. So algorithms have to be hosted in the server and running at some expected intervals, because this is an ongoing it's an ongoing event. So throughout the day, we have to identify uh, the buses that are running, and uh, the frequent the we have to continuously process the AVL pings. So the algorithms have to be running at the expected interval. So probably every run of the algorithm should be completed at say some 60 seconds, or whatever is the expectation set. Second is, like I mentioned, there should be program deployed to continuously process the real-time location of pings received. So the assumption that we have made is BMTC will make available to us these GPS pings in the form of an API, where we can just query and retrieve the pings that are required, say every minute, because right now the frequency at which the pings are captured is every 10 seconds. So at least every minute we should be able to retrieve the pings from through API is our assumption. And web dashboard to check the live location of buses and other performance indicators. One additional thing that we require is an onboard Android device, excluding the AVL unit. This Android device, the assumption is we have developed an app which we will deploy on the Android device, and will be kept near the in the proximity of the driver without hindering his driving view. At the same time, he should be able to access the user interface of the app, which will give instructions for delaying the bus. So there should be communication uh, that is happening between the algorithm that is hosted in the server and the onboard Android device. Again, we have relied on currently there are different communication technologies that we have explored. Like for example, the simplest is through REST APIs, and the next is through Google Firebase, uh, just a push notification through the Firebase. But for now, the pilot that we are planning is through REST APIs. Dependency with the transit agencies, like I mentioned, we need to have AVL pings in real time. And additionally, apart from the AVL pings, we also need to know the schedule information on daily basis. The schedule should tell us the vehicle, crew, and the ETM assignments to different routes. Only then we will be able to filter out and retrieve the pings that are only required for us for processing. And access to other information, static information, like routes that are currently operational, the bus stops that are currently operational, either through REST APIs or as a periodic dumps. And apart from these, the requirement for pilot testing is we should be able to tutor and train some of the crew members on which the corridor on which we are planning to carry out the field. So they should be trained with the user interface saying that if you see this particular signage, they should delay, they should depart, etc. So these are the two main UI user interface that we are proposing. The one on the left is the UI for the onboard device. It's a app that's running on the Android device. It will have additional information compared to what we saw in Tempo, like the route, vehicle number, and the current stop. Because uh, with respect to BMTC schedules, what we have observed is uh, the same bus can be running on different routes on a given day. For example, morning it can be running between Silk Board and say Wipro in the Electronic City on the flyover. Sorry, on the flyover, and then during the day it can be running on another route path, say somewhere on the other towards the Wipro and the Banshankari side. So we have seen such schedules being operated. So we wanted to get confirmation from the crew that probably this is the vehicle number that they are running and this is the route that they are currently operating on. So that's why we have this UI
So,
addition.
yeah, Yogalakshmi, did I interrupt you?
Yeah.
I just wanted to know whether this is a live dashboard.
This one is a live dashboard, and currently we have tested these two things within IASC with the help of students being treated as a proxy for buses. It's working fine. So we want to take it to the field for which we need some support from BMTC. So currently we are working on that.
So
So
is this
this
on Tableau? Because
this one is a user interface developed by CDAC, is a web user interface.
what is the name for this?
Right now we have kept as Samvahan. CDAC has chosen to keep the name as Samvahan.
And is it open source?
No, I don't. I am not exactly sure on that.
Okay. Thank you.
This is the user interface that we planned on the uh, app that will be kept on the onboard buses. And the right is the web dashboard, which has the live location being displayed. In addition to that, we are showing few other information like the trips with the loads that we currently saw as a load profile, and the average headway between different buses that are on the run. So if there are four from the morning at different points of time, what was the average headway seen in between different buses? So those sorts of information. So this upon clicking this, we will lead them to further analyze these things. So those interfaces I have not kept it here for now. So just to give a glimpse of how we plan to implement or carry out some pilot testing in the field. So this is an ongoing work. So this, as we speak, the user interfaces are refined based on the feedback that we get from the testing that we carry out within the campus. So we are still working on some of the minute things here. So one important thing, like I mentioned, is whatever delay that we compute at the server level has to be communicated to the onboard device. So that communication technology, right now we have set it up as through REST APIs. So the mobile device that we set up on the a bus will have to query upon entering the designated control point, query the server for any hold times or any delays that was computed for this particular bus for this particular trip. So if it has computed, then it will no retrieve and display the same on the UI. So that's how we have designed right now. Which is working in for few trials that we have conducted inside IASC. So we have to see how it will pan out when we take it to the field. So some of the challenges that we faced is, like I mentioned, algorithm should handle missing AVL pings in real time. So what we have seen from inside testing campus also, at some points of time, we don't get internet and the location pings were not getting captured. So in those cases, how is the algorithm going to react? How much it can wait and how much missing pings it can take, and it can try to estimate where the location could be at given point of time. So those things are being handled. So the route deviations. So we should exactly look at the pings only within the geofence area of the route path. So any pings that are captured outside the route path will not come into picture. So if there could be, this is because there could be errors in the pings itself. So the GPS will not always send out the correct locations. So there are some errors that come mentioned with the device itself. So those sorts of things also should be captured, and the timestamp of those missing pings or the deviated pings are very important, because when they are at control stations, we should know that they are at control stations. If we don't know, then yeah, that's the cost that we have to trade off. And currently we don't have any information on trip cancellations that take place in real time. So the ITS and BMTC does not capture all those things. It only gets captured probably end of the day when the crew comes back and tells the depot manager, and then the depot manager enters into the system. So we don't know if the trip is getting cancelled or not. So those information will play um, uh, a crucial message for our purposes to handle the bunches. And right now we have only operated out of the schedules and the GPS pings. We have not taken, our algorithm has not taken into consideration the ticket sales or the demand right now. It has just worked out through the schedules and the pings that it has seen through the historical data. So the plan is to include crowding information or to get some rough estimates based on the revenue that was reported uh, for each of the routes, and see how best can that be included to see. This would be important because explicitly there are 3 or 4 buses scheduled to depart at a given point of time. So why is it so? Whether this plays an important piece of information to handle those scenarios. How much can we delay in those scenarios? So for that reason, this piece of information becomes important. So we are working on that as well. Some of the opportunities going ahead is, right now the pilot we are planning is only for one route 500D. So for other high frequency routes, if we enable the same, how are the buses going to interact within the network? So we will have to see, and that's a good opportunity as well. So, and apart from that, when we extend or scale it up to other routes, we can think of scaling it up at a corridor level. For example, the same stretch of segment which contains 4 or 5 bus stops can be overlapping with multiple routes. So such corridors can be identified, like the trunk roads in Bangalore are examples where we can see multiple route buses arriving one after the other, and how is actually the demand varying there, and do we at the first place, do we need to handle the bunches at that level, or how much bunching can we tolerate at that level? So these are some of the questions that are in our mind to take forward in this regard. So any questions? I think I jumped my time.
Thank you, Yogalakshmi. It was a very interesting talk. So I think and we also started a
Sorry.
little bit late. So I think it's okay. I mean, it's not too much beyond the time. I have one question actually. A couple of question and discussion points is that like how generalized. I'm assuming whatever you've described is quite general. I mean, it doesn't matter. You are doing it for BMTC, but if the data is available from other places, you should be able to do that, right?
Yeah, as long as we know the structure of the data, and despite knowing the, at what I can say is we need not even match the column names or the field names in the database level. As long as we know that I have kept the algorithms input to a minimum level of just the root number. So if you give me the root number, I can spit out no the delays that have to be computed for various buses. So having said that, the other information, what is the structure that we need to have for other information, the how the bus stops are mapped with the routes, and what is the order in which they are visited. So these are very very in a very structured way with respect to BMTC. So at least that's what I have seen so far. So
I mean, if there is sometimes there are different structures, and most of them are actually they can be aligned to something like
yeah,
CTF kind of a thing. Then I think so. Why I'm saying is that I would be very interested from IUDX's point of view that we have data from say Surat. We have live data for buses coming in from Surat, and exactly most of the fields I think, as far as I know, matches. So I wanted to know at least the preliminary analysis that you had showed initially. Is it possible that I can point you to a database and some initial things that you've said, stop schedules, everything, and then the output comes out? Like, is it to that level, or do we have to do something more? And is the code available? Can our engineers look into it, or do we have to? Um,
uh, yeah, from my perspective, I can make the code available. I will just have to have a word with the profs at the department so that they are
okay.
also in agreement.
I mean, not like we can think of it in a more structured way. I mean, I
Yeah,
was thinking that if we could think of it as a kind of a tool, and the tool's
sure,
inputs, we can define that, okay, this is the database for say 3 months for buses, and this is the schedules, this is the stop information. As long as this is provided, then output will be given as follows. And that
sure.
tool, the tool can be, the code can be yours, and then you can plot that and see whatever we want to do. Because we have a live data coming in right now from Surat. Maybe there are other cities very soon we are going to onboard where again these ABL pings will keep coming to us, right? But again, I mean, it's right now because of pandemic, not all the
Yeah,
buses are fully
running.
functional. But then I think within a couple of months it will be. And then, so for example, in Surat, we even have AFCS data coming in, like the automatic fare
Okay,
collection,
fair
right?
collection. Okay,
So then I think maybe it will be nice to see whatever your analysis and tools are there. Can those actually translate into something like there? Because there I think we may have live data, as well as possibly some chances of taking it to the field also. So
sure, sure. Yeah, yeah. Uh,
Yeah, so there's one question from one of the participants, Mr. Panthamil, and he's asking that is the BMTC data open for public?
no, unfortunately, no. The
Okay.
BMTC data, so there is a MOU between SysTup and BMTC in lieu of a funded project with MAITI. and they are also one of the collaborators in that project, and hence, based on the MOU, there is a data sharing happening.
Okay, fine, fine. Okay, so any other questions from the participants? You can either write it on in the chat box or maybe raise your hand. We'll wait for a couple of moments. Okay. So, well, I believe there are no further questions. Abhay,
Yeah.
do you want to?
Yeah, I mean, yeah. Thank you, Yogalakshmi, for a great talk. And I think it will be if it's possible, we would like to make these slides available, and so that would be
Sure.
helpful. And yeah, thanks once again. And then if there are no further questions, then we can close the session.
I would like to thank the whole IUDX team and the audience for giving me an opportunity to share my work. I would have a word with the department chairs, and I would try to set up a meeting with IUDX to take this forward. Hope that helps.
Definitely, I mean, I would be really interested if some of this work can be like again made into some kind of, as I said, some tool which is like, see, when the data comes from Bangalore or from any other city, and we are able to give the same kind, generate same kind of outputs. I think that is repeatable across the cities. I think that will be a really good contribution if we can take it to that level, right?
Sure. Yeah.
And
Thanks.
Yogalakshmi, one last thing is that you told that this dashboard is developed by a CDAC, right?
Yeah, CDAC Thiruvananthapuram. So
Okay,
they are also part of
okay,
collaborators.
how do you spell it? Like some Wahak, how do you spell it?
CDAC.
no, see that, but it's some Vahan, right? Some Vahan.
Samvahan.
I'm not sure about that. Sorry.
So
So the
that, so
Jyotirmay,
that
I
is,
know you are asking.
okay,
You are asking. Samvahan is the name of the product. It's not the tool that is used for
okay,
dashboarding.
Oh,
okay, okay, okay. That is the AVL probably, right?
yeah, yeah.
Okay, I see.
Okay.
Acha, acha, acha.
Oh,
Okay, thank
Okay,
you
yeah,
very much.
thank you. Yes, thank you.
yeah.
You can close the
Thanks.
session. Yeah, thank
Thanks,
you.
everyone. Thank you.
Thank you.
Bye.